All right, so today's notes are on reciprocal functions. Our content objective is to graph reciprocal functions, and our language objective is to use the correct terminology to describe them. A reciprocal function, first thing we're going to define or talk about, since that is the topic of today's notes, is a function in the form y equals a over x minus h plus k. So again, rational function or reciprocal functions are coming in our rational function unit because our variable x is in the denominator. These functions end up taking a form like this. So you have two separate wings, or what are called branches. So these are called the branches of the reciprocal function. So you end up with two separate branches on your reciprocal function. And that's what as a result of the two asymptotes that we'll get to in a second. So before we get to the branches in more detail, A is, again, just the AH and K are the same transformations that we've learned about in all of our function units. So A is the stretch or compression again. If A is between 0 and 1, it's going to be closer to the center point. So it's going to condense in, compress in towards the center point here. If A is more than 1, then it's going to stretch away from it. So again, if A is between 0 and 1, it stretches or it compresses towards the center point. If A is more than 1, it stretches away. H is the horizontal shift, so that again moves it left and right. So our H value down here, again, is always the opposite because there's a subtraction in the equation. So if it were x minus 3, it would actually move 3 in the positive direction. X plus 3 moves 3 in the negative direction. And H is also very important in these graphs, or tells us some super important information, because it tells us when our denominator would be 0, which results in our vertical asymptote. So our vertical asymptote, the line that our graph gets infinitely closer to in the vertical direction but never quite reaches, is always going to be at x equals h. So x equals h, this value here, will always be our vertical asymptote. So if you don't remember the term asymptote from our exponential functions unit, it is again a line your graph approaches but never quite reaches, or it gets closer and closer to but never touches. Thus, because you have an asymptote at x equals h, your domain would be x is not equal h. So this is the same restriction rules that we learned about in our rational expressions. Nothing really new here, but just now you also need to connect it to the fact that not only is it a domain restriction, it also is a vertical asymptote for our graph. So it's a value our graph gets closer to but never quite reaches. Along those same lines, the branches will also have a horizontal asymptote, which is a result of K. So K is our vertical shift. It moves it up and down. And it will result in our horizontal asymptote. So your horizontal asymptote will always be at x, or y equals k, and thus your range will be y does not equal k. So because that's an asymptote, it means your graph will never quite reach it. It can't be in your domain. So your k will tell you your range and your horizontal asymptote. One thing I want to note is when you talk about domain and range, you're talking about values they do not equal. So it does not equal. When you write the asymptote, you write them as equal to. So you write an asymptote as equal to, you write domain and range as not equal to. So first problem I want us to do together, I already started part of it, apologies, but we're going to sketch y equals 2 over x plus 3 plus 4. First thing I want us to do before we ever sketch is determine the asymptotes. So because the asymptotes are lines we can't cross, they're definitively not going to cross these lines, we have to first identify them. So I found my vertical asymptote by looking at my h value. So again, I switched the sign, so x equals 3 is my vertical asymptote. You can also say your domain is x does not equal -3. And then I drew that as a dotted line in the vertical direction. So I went to x equals 3, drew a dotted line there. I did the same thing with the horizontal asymptote. And thus, as a result, I know that my range would be y does not equal 4. So I drew a dotted line there at y equals 4. And I know my graph will not cross that line. The rest of it is just like any other graphing problem. You're going to plot or make a table, calculate it out, plot your points. Sorry, this is super tiny. Actually, it's probably for the best because now you'll be forced to do this math out on your own if you can't see this on your screen. So if you can't see this, please do this math out on your own. But I made a table. I made h, so -3 is my h value. I made that the center point on my table. And I actually know that it'll be undefined at that point because that's where my asymptote is. So I'm not going to have a y value that goes at -3, but I'm going to find 2 points before it and then 2 points after it. So if I plug in -4 first for my x, so I have -5, -4, -3, -2, -1 as the x values on my table, because again, put -3 in the center, 2 before, 2 after. I plug in -4, I get 2 over -4 plus 3 plus 4, and that became 2 over -1 plus 4, which when I calculate that out becomes -2 plus 4, or just regular 2. The next one I plug in -5, so I have 2 over -5 plus 3 plus 4, which became 2 over -2 plus 4, which is -1 plus 4, or 3. So I'm going to go to -5 and then 3 and plot that point. So now I get a sense that it's going to go something like this. I know it won't cross my asymptote, so I'm not going to draw it crossing them, but I went through those 2 points and I drew a branch that looks like the branches in reciprocal functions, and it goes through those 2 points. Now I'll do the other side. So I have 2 over -2 plus 3 plus 4, which becomes 2 over 1 plus 4. 2 over 1 is 2 plus 4 is 6. So I'm going to go to -2 and then 6 and plot that point. And then last but not least, I'm going to plug in -1. So I have 2 over -1 plus 3 plus 4, and that becomes 2 over 2 plus 4, or just 1 plus 4, which is 5. So I go to -1, 5, plot that point, and now I have the other branch that I can sketch. Just make sure you never cross the asymptote, and now I have my reciprocal function. So there's our sketching a reciprocal function. Pretty straightforward. Find your asymptotes, make a table, plot your points, sketch it out. Last thing I want to do really quickly is go over finding the x and y intercepts. So our last example that we're going to do together, I want us to determine the asymptotes, domain, range, and intercepts of the function y equals 1 over x plus 2 plus 1. So first thing I'm going to do is the asymptotes. So my asymptotes, again, I know that I'll have a vertical asymptote. So notice vertical asymptote, I keep abbreviating VA, that's just so I don't have to do all the writing. My vertical asymptote will be at x equals -2 because I just switched the sign for x and now, or for my h, and I have my vertical asymptote. My horizontal asymptote will be at y equals 1. And thus I can also figure out my domain, which would be x does not equal -2, and my range, which would be y does not equal 1. So again, when you write the asymptotes, they are equal to. When you write the domain and range, they are not equal to. Now I'll find my intercepts. So I'm going to start with my y-intercept. And this is always when x is equal to 0. If you forgot that key point about intercepts, y-intercept is when x is 0, x-intercept is when y is 0. That's how we're going to solve it out. So all I'm going to do for the y-intercept is plug in 0 for x. So I have y equals 1 over 0 plus 2 plus 1, which becomes y equals 1 over 2 plus 1, which is just 1.5, or 3 over 2, or 1.5. However you want to write that. Now I'll do my x-intercepts. So again, x-intercept is going to be when y is equal to 0. So I'm going to plug in 0 for y, 1 over x plus 2 plus 1. I'm going to subtract 1 from both sides. I get -1 equals 1 over x plus 2. So again, this is where our rational expression stuff comes in handy. I'm going to multiply both sides by x plus 2, or you can think of it as cross multiplying, but I end up with negative x plus 2 equals 1. So I multiply that on both sides. I'm going to divide away my -1, and I get x plus 2 equals -1, subtract 2, and I get x equals -3. So my x-intercept will be -3, 0. Sorry, I didn't write my y-intercept as a coordinate point. It'd be 0, 1.5. And those are all of our examples for today. Make sure you write down any questions, comments, or concerns you have on this stuff so we can go over it together in class.